we're going to be simplifying this rational expression. And the first thing I'm going to do is take care of this numerator. So I have 2xy to the third power. So that means you're raising 2 to the third, the x to the first to the third, and then the y to the first to the third power. So 2 to the third is 2 times 2 times 2, which is 8. So my numerator will be 8. And then if I have x to the first raised to the third power, what you're looking at is this rule that says if you have a power raised to a power, you multiply the exponents. So 1 times 3 is 3. Same thing for y to the first raised to the third. If I multiply those, I get 3. And I'm just going to write my denominator exactly the same. So from here, the next thing I'm going to do is simplify 8/20. So 8/20, if I reduce, I would divide by the greatest common factor of 4. So I would get 2/5. So I'm going to rewrite as 2/5 x to the third, y to the third, over x to the -6, y to the -7th. The next thing I'm going to do is locate my negative exponents. So I notice that I have a negative exponent here in the denominator, which is going to switch to the numerator because a negative exponent is just the reciprocal of the positive exponent value. And same thing for my y to the -7th, it's going to switch to the numerator. So when I rewrite, I have 2x to the third, y to the third, all over 5. And then what I circled, I'm going to be bringing those to the numerator's position. So I would have x to the 6. So I move this one up. And then this is moving up, so that's y to the 7th. All right, so taking a look at my numerator, I notice that I have base x here. And I'm using this rule because they're being multiplied together. So the rule says add the exponents. And I'm going to do the exact same thing for base y. They're being multiplied together, so I'm going to be adding the exponents. So my final answer here, I have 2x to the, well, I have 3 plus 6, so a total of 9. Y to the 3 plus 7, a total of 10. And that's all over 5.